And I'm going to ask Stuart if there are any problems with slides or hearing me, just to please let me know. So I'm going to tell you a little bit about my experience in leading SESYNC, as well as about SESYNC, what we did and some of the lessons that we learned. I'm going to start by telling you a little bit about some of the things that went on related to my research that really motivated me to propose the development of such a center to the National Science Foundation, which we're very indebted to for providing almost all of our funding. The University of Maryland also contributed substantially. So my own research has been focused for many years on water systems, as Gabrielle mentioned, particularly rivers and streams. We have a lot of beautiful ones around our country. And of course, Oceana, you have fantastic ones down there as well. Unfortunately, many of these look much more like this. They're impacted by urbanization, and you see all sorts of ugly scenes, lots of erosion and incision, and a variety of other kinds of problems in the ag streams. A lot of them, of course, have a lot of excess nutrients in them and are polluted also with pesticides and herbicides. So, whoops, I realize I just jumped too far. Instead of trying to go back, I'm going to say my work has then evolved to focus on restoration of these systems, because it became so clear that just studying their basic dynamics was really increasingly hard in my own research. I had to travel further and further from areas that had what were viewed then as sort of pristine channels and rivers to ones that in fact were less and less impacted. So the basis behind restoration from a research standpoint is that you need to restore processes. That's what the last slide showed. Things like the ecology, the biodiversity, the flow dynamics, the inputs of organic material to the system. That is things that are not related necessarily to how a system just looks. In reality, however, what has been happening in the US and many parts throughout the world is that channels have become engineered. That is, that they're restored not necessarily to reverse the damage to the processes that support healthy rivers and streams, but instead they're engineered to look like a stream is believed it should for a particular region, and to be able to handle the flow and the sediment that comes to that stream with little attention paid to whether or not that can be supported over time, given the context within the watershed, the inputs to that, and of course, never mind the pollution. So channels, streams and rivers really haven't been restored the way science has moved forward. Now, one of the reasons that it went in this direction to be heavily engineered with approaches that are almost formulaic, that is, if you get the slope and the width and the depth in the right formation, you're going to have a healthy stream. One of the reasons it moved into this direction is, and this shows you what some of these highly engineered streams look like. So sorry for jumping ahead. They have these really interesting sinuous channels that you rarely see natural streams having. They often are, because they've been engineered and the processes that support them, namely the flow dynamics and the landscape around them, haven't been restored. They're often, bolstered with all sorts of large structures to try and keep them in place. So not at all like a natural stream. Now, why is this the case? Why did it move in this direction? Well, there's a lot of work that's been done on this, particularly by one scholar, a political ecologist by the name of Rebecca Lave, who's at Indiana University. And what she has been able to show is that, pretty convincingly, I believe, that the social drivers really have determined how these streams and rivers are being restored, namely that it's big business now. And interestingly, a lot of it revolves around a single iconic figure who came up with what I would call sort of a cookbook restoration approach, where you can essentially identify the kind of channel you want to create, and there are stepwise methods for doing that. But more importantly, and I should say Dave Roskin, who's the person that came up with this particular approach, it's called Roskin restoration. More importantly, one of the things Dave did was he recognized that there was essentially a vacuum in terms of providing guidance on how to restore rivers and streams, but a lot of governments, countries, local and national level wanted to know how they should be going about this process. And so he developed this kind of approach to fill that gap. He also set up a series of courses that you could take to become certified in using his particular approach. Now, as you might imagine, it's not cheap to do this. One course, which is typically a 5, sometimes 6 days, is now between $6,000 and $8,000. Lots of money to be made off of this. And so what Rebecca Lave argued, that the neoliberal emphasis on the privatization and commercialization of knowledge fundamentally changed the way that science not only is funded, but how river and restoration is being done. My simple point here is that what I began seeing in the kind of work I was doing is really the predominant role that social dynamics were playing in what was being done. Even more close to home for me, I do a lot of work in the Chesapeake Bay watershed, a very large estuary, and I work on the streams and rivers in that watershed. For many, many years, those streams and rivers were being restored to get back what that stream and river historically had been, or at least in its current context, if that could not be accomplished, to restore it to its best possible condition in terms of the ecology, namely the biodiversity, the natural flow dynamics, etc. Over time, that shifted, and it became a process whereby rivers and streams were being restored to help fix the downstream Chesapeake Bay proper, this big estuary. So these are freshwater rivers and streams. And what was being done was focusing on the fact that too much sediment and nutrient was reaching that Chesapeake Bay, and people wanted the oysters back that were dying, and the blue crabs and the striped bass that they like to fish. Fundamentally, what happened then was that how streams were being restored changed dramatically. So first of all, instead of focusing on restoring what we think are essential components of streams, the restoration projects were focused on reducing the flux of nutrients and sediments downstream through that stream. And essentially what happened was that many of the streams in my state, for example, that are highly eroded, have been transformed into stormwater system complexes. So they've been filled, they've been created wetlands with real small riffles in them, nothing like what a stream historically has been defined, and none of the biodiversity known to be native to the streams. All of this essentially because now the streams are being used to restore the bay. So basically what we saw happen is that how streams are restored was changed dramatically due to social forces to improve the Chesapeake Bay. Over time, I even began to see that restoration was redefined so that certain policies were changed such that converting a stream to a stormwater management structure was defined as restoration. Eventually, even because doing that, filling a stream and changing it dramatically violates our Clean Water Act in this country, the nature of those streams was redefined. That is, suddenly they were no longer streams, but they were viewed as erosive structures that had not historically been streams. So the point is that everything was so driven by social dynamics that it became clear to me, no matter how much environmental science I did, looking at the hydrology, the biodiversity, etc., if I didn't start focusing or thinking about social processes, then we weren't going to make a lot of progress. Other evidence that this is a social process and that there are social consequences. property values are linked to what's going on in streams and if they've been restored. Interestingly, willingness to pay for restoration projects is very socially split. That is, those that are in the best position in terms of their socioeconomic status or have been shown to be the least willing to pay for these. And yet most of the restoration projects that happen tend to occur in those areas of higher socioeconomic status. And I've already mentioned that markets essentially determine the approach. So the fundamental issue is that all environmental problems are social problems. And so my view and that of my close colleague, Jonathan Kramer, was that if we really wanted to make a difference, we wanted to start enabling more communities of interdisciplinary communities that involved environmental scientists and social scientists to approach some of these difficult problems. That led to proposing the center, SESYNC, the National Center for Socio-Environmental Synthesis. And our idea there was that it would foster not only research at the interface of the social and environmental sciences, but that it would foster actionable research. That is, research that meant more, that meant something to others besides just those academics in the community. And let me tell you a little bit how SESYNC worked. As a synthesis research center, we supported teams from anywhere in the world. They could come to SESYNC and we supported their travel. We did not pay their salaries generally, although there were exceptions to that. The idea behind synthesis is it's a research method. So these teams we supported came together at the center and brought data, models, theories, and the goal was to integrate these to develop potential solutions, or I should say distributions of solutions to different kinds of problems related to how people and the environment interact and the consequences for both people and for the environment. What we did was we allowed people to submit proposals for 2 to 3 year projects. Each year, the teams would meet at SESYNC anywhere from 2 to 3 times for 3 to up to 5 days at a time, working together. And then in between, when they went back to their home institutions, they completed some of the work they needed to have done before they met the next time. And so it really was a center that was there to foster the interaction among these teams while they put together the data and information they needed to address a particular problem. Just to back up a little bit, just to remind you what I mean specifically by a socio-environmental system, basically we're talking about a problem that's couched in terms of social dynamics and also natural dynamics. And so the whole idea behind doing integrated or synthetic research at this interface is being able to link these, which is a very non-trivial thing to do. Figuring out how to move from how, for example, some fundamental ecological process like water flows actually influences human outcomes and behaviors, and how that in turn feeds back to affect environmental dynamics is not an easy thing. What SESYNC realized very early on is that there were a number of challenges in dealing with socio-environmental systems, and particularly in bringing together highly interdisciplinary teams, the kind that would require people from all sorts of different disciplines that hadn't worked together previously. So I'll just mention 4 of the big challenges we had is that when you work on socio-environmental research, it's highly interdisciplinary or transdisciplinary. And my definition of transdisciplinary is, there's lots of definitions, is that it involves those that have some interest in the outcome. It could be sort of what we think of as traditional stakeholders, let's say, fishermen or fisheries companies dealing with fishery problems. But it can also be something like NGOs that have a particular interest in moving an area forward to affect policy change, but need some scholarship to support that. The kinds of disciplines that were represented in our teams at SESYNC was hugely diverse. So some teams might have an archaeologist, a human geographer, an economist, for example. So basically, these are people coming together, and I know the NITRO group is familiar with this, who had hugely different epistemologies and use very different kinds of methods. Natural scientists like myself don't have, training or histories of working with people who do ethnographic research, for example. So this was a big challenge. How was SESYNC going to try and help teams overcome some of these big differences? The second big challenge we had is that the nature of the problems that are faced when you focus on the intersection of people and the environment are so-called wicked problems. That is, they tend to be very ill-defined problems. Everyone has a different view of what the problem actually is, or if there even is a problem. They also tend to be highly value-laden. This can be both personal, it can be political, it can have to do with one's upbringing. So this is different from just the disciplinary perspective. So one person's solution to a problem can be another person's, problem. So for example, in the work I do, if we talk about, trying to improve urban streams, one of the things we focus on is reduce impervious cover, get rid of some of the asphalt in the watershed and increase infiltration. Well, some people really like the neat, nice look. And then, of course, you also have people who have business interests in developing, et cetera. Another one of the challenges, which I actually consider a grand challenge, it's not unique to studying socio-environmental systems. It's simply that that socio-environmental systems are examples of complex adaptive systems. And what we mean by that is that when we talk about the components, we're basically talking about a system of system settings where you have, multiple subsystems. These can be regional in the environmental context. It might be regional landscapes. It might be regional biodiversity, but these interact with local dynamics, such as changes to the waterways that flow through some of those regions. These in turn interact with social dynamics. So the important point here is that the interactions occur both across social and environmental, but also across scales, but of both space and time. Many of the social dynamics operate on much longer time scales in terms of change than do the environmental dynamics. This is not that different from other kinds of complex adaptive systems like the economic markets, the global or more regional ones. Adaptive refers to the fact that changes in one system affect changes in another system, which in turn have feedback. So they are viewed as sort of adaptive. So lots of nonlinearities, the possibility for state changes, and high uncertainty. The fourth and final challenge I'll mention is that the kind of research that is done when you study these systems, really they're almost all geospatial. That is, they tend to be place-based. So context really matters, whether it's the local cultural context or it's the geography, the climate, et cetera. And this kind of synthesis research we're talking about, where teams come with data, theories, et cetera, is also computationally very difficult because you're combining very different kinds of data and sometimes huge data sets. So for example, much of the social data is increasingly coming from things like Twitter or through Flickr photographs, never mind textual documents, which are more traditional and less computationally intensive than some of the other kinds of resources. So new modeling approaches are incredibly, I went backwards. I've never been able to manage to get these to go back, so I apologize. So one of the things that I wanted to focus on now was to talk about how we overcame these challenges. And the first thing that I'll note is that the current state, this is so well put in this article by Betsy Rowland, that she wrote in 2021, the current state of team science intervention development is such that initiative directors like me and many of you out there and translational scientists who work in our lead team science initiatives have been left to identify ways to implement strategies or interventions in their local context without any guidance as to how they can do so with fidelity. So one of the first things I did, because I think this is the slide I skipped over, is I read a book by Stephen Fior on cognitive metacognition in teams. And I read that, I believe it was in 2012, maybe. And that book was written by experts in the science of team science. The whole book really was nothing but theory. And when I read that, I spent a ton of time thinking about how can we take some of these theories about what promotes effective teams and translate the theory to something we can actually do on a practical level at SESYNC. The other thing I want to note that's relevant to this quote by Betsy is that it wasn't until 2015 that in the US, at least, the National Academy of Sciences came out with sort of their first study on the science of team science. And they did sort of summarize what we knew today, but it was very basic. And again, it wasn't focused on actually doing the kinds of things many of us want to do, which is to try and facilitate the progress by teams and to move, science and scholarship forward in this particular arena. So one of the things that you all, I think, are probably very aware and that we found, we were aware of in advance, but I think we were still shocked at how relevant this statement is, that researchers can be really willing to actually, in our case, take funding to join interdisciplinary endeavors and projects. But bringing them together, no matter how smart they are or well-intentioned, is absolutely no guarantee of success. And so some of the things I'll tell you about the lessons we learned were really related to this lack of preparation for teams to undertake this kind of work, yet the real belief that but many of them really knew exactly what they were going to do and how they were going to do it. So what SESYNC did, I do want to mention, we developed a theory of change, and this will help explain how we then, from this, developed the processes we use to try and facilitate teams, and then I'll move into some of our, informal lessons learned. First, we had to say, well, what do we really want to accomplish? Well, ultimately, we really hoped that we would grow communities of scholars doing interdisciplinary science, socio-environmental science, that would have, strong knowledge of team practices and really, produce scholarship that made a difference. That's pretty far up there, right? And one of the things we focused on with a wonderful facilitator for development of our theory of change is that you can only really think about where you can be, your horizon of accountability, where you can take credit for what you do. So we sort of backed down through a process saying, okay, what kind of impacts can we have, beyond our immediate alumni? What kinds of impacts can we have on our alumni? And what are the immediate things we think we can probably show that we can do? This is sort of related to our theory of change. Then, what is it we need to do? What are our objectives, our core objectives, and our programs and our processes we implement at the center to actually accomplish those things? Namely, help teams produce actionable synthetic research in socio-environmental systems and build capacity to do this kind of team science. And that includes both the competencies and the dispositions. So to accomplish that, we then focused on setting up things to accomplish 5 core objectives. And I'll talk briefly about each of these, but basically we wanted to figure out how we could enhance interdisciplinary collaboration. What could we do to make it easier for teams? We also wanted to build new communities that went on to do more work after they were engaged at SESYNC. We wanted to hopefully enhance the extent to which teams of scholars were actually focusing on doing things that made a difference and that they actually worked with some of those who could potentially use that knowledge. So we call these knowledge users to try and recognize that they're not all what we think of as traditional stakeholders. In our case, computational capacity was important, and education programs about both team science as well as socio-environmental systems was important. So the programs we developed to accomplish those things, these don't match one-to-one. I can't say like our workshop program, you know, met that specific objective or core objective within that 5 areas. It's that these things together were designed specifically to accomplish those core objectives. One was just funding teams, that we call it our Pursuits program, focused on specific problems they posed in highly interdisciplinary teams. We had a graduate program, which I'll mention later, a postdoc program I'll mention later, and then Gabrielle, when she introduced me, mentioned the Foundations program. This turned out to be really important, so I would encourage all of you, if you're leading organizations focused on things that require a lot of team science, that really beginning to think about proactively recruiting teams for research and work in areas where teams don't seem to be proposing that type of work, that is focusing on novel methods or understudied problems. And so what Gabriel brought to SESYNC, this idea of bringing directors and major research centers that wanted to do this together, wasn't being done. So that was something that we funded proactively. We didn't say, oh, well, it's an open competition and everyone submit a bunch of proposals and they'll go through highly competitive peer review. We had research fellows, sabbaticals, et cetera, and then we had training and teaching programs. I won't have time to go into that, but I will mention in a little bit later that that was an important component because there are important skills that need to be developed that most researchers don't have access to ways to help develop those skills. Now, I'm going to mention what is core to how we work. So I talked about our programs just now. Now I'm going to talk about the process. And this is basically what our staff and Jonathan and myself and Jim Boyd, who was an economist who was also part of our senior leadership, put into play to try and maximize the team's success. Most of this is focused around team science. And so I'll just go through a few of these pieces. So one of the things we did was we recognized that teams may need help in putting together proposals because this was a new kind of research that we were pushing. Communities didn't really exist, and people weren't used to this level of highly interdisciplinarity that we were asking for. So we didn't just say submit a proposal, and I should say these are short proposals, like 5 pages at most. Submit a proposal and it's up or down and you come back in a year maybe and try again. We wanted to make sure they could talk to us first, that we would interact with leaders of potential leaders of teams before they ever applied, that then when it went through a review process by a highly interdisciplinary peer panel, that we provided feedback to them and allowed them to rapidly iterate and respond within a period of 4 to 6 weeks. And about 50% of the proposals we actually reviewed went through that rapid iteration. Very few proposals actually made it automatically to being funded. And I'll talk more a little bit later about what some of the reasons for that were. The next thing that we did was that we insisted that all teams, the leaders of those teams, and we usually encourage 2 to 3 team leaders, join us in a planning webinar. And by us, I mean a group of leadership people from SESYNC, myself or John, head of our cyber programs that would help facilitate some of their work, our communications. And the goal was, and this was something that came straight out of me reading Fior's book, in which he talked about how essential it was to sort of make teams aware of what kinds of hurdles they might be facing and help them prepare and to revisit that often. So what we did was ask them to talk about their goal, what they were trying to do with their research, what kind of data they had, who their team members were, and just enter in an informal and relaxed dialogue with them where we would subtly raise some of the issues that they could potentially face. What if you have team members that blah, 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 blah. So the point is to to sort of approach this in a very gentle way. These are smart people, right? And many of them have done a lot of work in teams, not necessarily this interdisciplinary, but simply requiring that they present this to us and talk with us and think about some of the processes and tell us what kind of data and people they had in advance, got them thinking about it and prepared. So they didn't just show up for their first team meeting and then start figuring out how to make things work. We would work with them on how to design their meetings. This sounds like, many of the teams would say, oh, we know how to design a meeting and agenda. It's much more than that. And we actually have guides now on designing meetings, and we would iterate with them and go over some of the key things they might want to consider doing to make their meetings the most successful. We offered facilitation. We could not do it for every team because it is a labor-intensive process, and we had limited people on our staff who were really good at facilitating. I will just mention that one of the key things here is this person has to be somewhat knowledgeable about the domain information as well as about facilitating teams. And so they play a very different role than if you've ever been in a meeting that's facilitated by a professional facilitator who basically just wants to make sure everybody is heard. That's part of it, but that's a very small part relevant to trying to help teams move forward. And then we try to be super flexible. So we would check in with teams almost after every time they met to sort of talk to the leads and find out how they did and figure out, could we do something more to enhance their success? And this could be, oh, you haven't had a facilitator, would you like one? Or you need more computational support. So continuing to check up with them. So all of these things combined, we think, had an impact on our team's success. Not all teams were successful, which I will point out as we go, but we did have what we think is a fairly high success rate. Okay, so what did we find? Now I just want to go over some of the things that we have found, some by the numbers, some by the stories. And remember, I'm going to focus on, research output and also building capacity for team science and socio-environmental system research. Remember, we used that theory of change. We built into our system, and this was really important, both formative evaluation that we did internally very rapidly over the first 2 to 3 years, an external evaluator that did a developmental evaluation with us after 4 years, and then we're just now entering our summative evaluation. And I'd say about half of it's been done, which involves gathering a lot of data as well as the external evaluator doing a lot of surveys, interviews, etc. Well, what can we say about that? Well, first of all, I want to point out that evaluating team science, as I suspect you're aware, is really hard. And there aren't standardized methods for this. There was a recent paper by Lawson, this was supported by SESYNC, this particular research. In their paper, they found from an extensive systematic review of the literature, looking at 888 unique measures of 40 standardized criteria. The most common form or criteria was integration. And even that was defined in more than 40 ways. So we don't have any well-developed methods for this. It's a huge area of research. We need a lot more progress in this. So I would say one of the areas we have felt most lacking has been how to measure, not, most people measure output, which is I'm going to show you, but measuring things like, do team members, did their ability to pick up on social cues from other team members and to develop not just a shared language, but a shared understanding and some of the social factors that were really important to make novel contributions. Did that develop increasingly over time among teams? Did SESYNC have any impact on that? This is hard stuff to measure. Now, just quickly, I'm going to do a few things by the numbers. We certainly did have an impact on interdisciplinarity in our teams. We saw, changes over time. By the fourth or fifth year, our teams had about 30% of their members were social scientists, but we had individuals from a variety of different disciplines. If you bring in the humanities, public health, and policy, it's certainly not dominated by the natural scientists overwhelmingly. Cross-sector participation was lower probably than some of you may have. About 75% of our team members were from academia. I can talk about why that's the case in the Q&A period if you'd like, but a lot of it has to do with who our funders were and what they charged us to do. We supported about 350 different projects, about 5,000 people, and it's resulted in, this is now over a year old, a lot more publications. So by the numbers, you know, we certainly have evidence that things went very, very well. Our graduate student research program, I think, had some of the greatest impact. We actually funded graduate students to do synthesis projects. We're one, at least in the US, one of the first synthesis centers to do this. We had them from many countries and many institutions. We supported 34 teams. These were labor intensive on our part because they got a lot of help. We got high diversity, and we were really pleased over time. We were able to shift the racial and ethnic diversity so that we weren't totally dominated by white participants as the years went by. They actually have done a fantastic job, at getting positions after they leave their PhD, and it's not just in academia. So this was a very successful program, and it is also it's the only one of our sub-programs that is going to have a rigorous evaluation where we had pre-work done on them and a rigorous social science study done on them over time, and that should come out in another 2 years or so. We had a very vibrant postdoc program, and they were highly interdisciplinary. They came in cohorts. On average, we had between 10 and 15 postdocs in residence at the center at all times. All of them were doing interdisciplinary research projects. Many of them worked together over time, and they were really prolific. They also did fantastic at getting jobs. So this old view that, you know, interdisciplinary work, it's hard to get an academic position, is not necessarily true. Also, not all of them went into academic positions. Now, what about the actionability? Well, I'm going to be honest and say, I think we only did a modest job at moving our research teams from highly fundamental work to more actionable work. Academics are really, you know, favored towards this end. Again, some of it is related to our SESYNC funders, but not all of it. I'll give you a few examples of kinds of projects that span this range. A very fundamental one was one that focused on whether or not ecosystem services like the fruits that come from trees that are sold on markets, whether or not the different trees that provide those services reflect phylogenetic relationships. There were some actionable implications, but it was pretty far down the path that one had to think about that. One that I would say is more in the middle, and actually they've done an extension of this that just came out in the last few months that's even more actionable, is a group that managed to integrate theories of behavior change into climate change models in a quantitative way. And by doing that, they were actually able to show that if researchers could show that climate-related impacts, like a major hurricane, could actually be attributed to climate change, that can influence views and behaviors that can result in reduced emissions. And so this is having some impact on what's called attribution science, which is the science of being able to attribute specific events to climate change. People really need that in order to be influenced and to remember those catastrophic events. But we did have some projects that really were far at the actionable end where they actually worked. For example, with natural resource managers. In this case, they worked with our group, our federal agency that deals with listing endangered species to help them evaluate different the risk to different species to determine where that agency is going to put their resources in developing recovery plans. All right, now some more, so what I call stories. These are the things that are hard to measure. We hope to have more come out from our summative evaluation that will tell us about some of these, but I wanted to tell you some of what I feel like we've learned. First of all, we found that identifying collaborators was a huge hurdle. That is, knowledge of other disciplines outside your own that focus on a particular problem. For example, I mentioned the climate change issue. You know, natural scientists and climate scientists have been working on this forever. Mostly they were unaware that social scientists like sociologists had been working on climate change for a long time. So this requires helping teams and helping them almost matchmake to learn what's going on in other disciplines that really could change the nature of their research. Something else that we learned is that functional team diversity is probably as important as disciplinary diversity. So when somebody came onto a team that used a very different approach or had really different ideas, due to their background or their competencies, this can have a really big impact on the direction teams take to produce more novel research. We also found that the more disciplinary diverse teams were, they tended to approach problems somewhat differently, and there is some evidence for this in the literature as well. We found too that approaching problems with a social orientation helped to bring teams together. So for example, if you think about the issue of water availability and you focus on that, you know, like water insecurity, and you focus on that in terms of water availability, teams automatically start to say, well, we need a hydrologic modeler. We need somebody who focuses on what vegetation does and how it influences the climate and about soil infiltration, et cetera. But if instead you focus on water insecurity from a perspective like water insecurity can lead to stunted growth associated with water shortages, suddenly people start focusing on things like, oh, well, what's the cost of water and who has access to that? And what are the land tenure and water rights? So we would often encourage teams to start out their first team meeting, and even when we talked to them when they were preparing proposal, to think about it as a social problem and then decide what kind of people they need on the team and what kind of data they need. Certainly, tools can accelerate research. I've already mentioned facilitation. There's all sorts of studies that have been done on co-production. Many of you know a fair amount about the production of shared mental models and the use of boundary objects. There's no question these are important and can make a big difference. Our introducing the idea of how to develop conceptual models as a team with everyone doing it independently first and then coming together could really made a difference in some teams, how they develop their project and how they move forward. We found that encouraging teams to focus on the very broad context and the causal paths could also shift thinking. And one of my colleagues at SESYNC, Jim Boyd, has developed a nice little brochure that I actually think is really good used in classes, but it can be used also with teams to shift the way they're thinking. I want to just reiterate this idea of tools and research that accelerate research. I've already mentioned boundary objects. These can be so diverse. And it was amazing what different teams would use. We could talk about these, but often they would sort of develop them on their own. Sometimes it was as simple as a map became the boundary object, sometimes a conceptual diagram, sometimes around a tool that the group could use. You may be familiar with Sanford Eigenbrod and Michael O'Rourke's Toolbox Dialogue Initiative. The way it worked was essentially to have a series of prompts, things that were stated to the research team, and each individual would separately respond. Do they agree, disagree? Where are they, say, on a 1 to 5 score with that particular prompt? And most of those prompts were related to team interactions, but not all of them. And then the group would discuss how the different individuals responded. It's that discussion around the response, the discussion around the conceptual diagram, or the discussion around the map that actually brings the teams together. It's not the tool itself, of course. We found for our groups that training made a big difference. Certainly, we did training in team interactions for our postdocs and our graduate students. We did not have the capacity to do that for the community at large. We did it for some individual teams. A lot of our training was around computational things that were needed for socio-environmental research. In terms of team processing, we witnessed that team conflict really can improve performance and innovation. It's not necessarily a bad thing, but that conflict needs to be around what they're doing. Where we saw problems was when it was related to relations. And so this is where tracking what teams were doing, paying attention to when they were having problems, and then doing what we would call gentle interventions, where we simply just would talk during a break, say, to the team leaders about what was going on and help them brainstorm ways to move beyond that. Shared leadership made a huge difference. It's really a mistake to let there be a leader or 2 or 3 leaders who always facilitate how the team moves forward. It really makes a difference in terms of buy-in and helps to level the playing field if there are issues related to hierarchies in, the social or intellectual interactions. So I want to bring this to a close because it's getting close to 9 o'clock my time, 1 p.m. for many of you. Did we have enduring impacts? We believe we did. We have lots of stories. We have lots of testimonials. We have things, and I don't just mean things we asked for, but things people sent us. But we also have our summative evaluation, which is going to use some of that, as well as a lot of data analysis that is currently underway. It'll still take us another 1.5 years, probably, to complete that. I like to end with this that somebody sent us on their own, saying it just changed the way that I've organized my research, I think. So I think I want to start more with the questions of what needs to be measured rather than starting at the point of what has been measured and what do we know about. It's unfortunate that that was the ending point instead of the starting point for my work. It's SESYNC, but I think really has affected the rest of our research trajectory as a group. Lots of fun with lots of people, and it's been a very rewarding experience to be able to lead SESYNC. So I'll stop there, see if we have any comments, questions, and I would love to hear some of your experiences, as I know other people on the call would.
Thanks, Margaret. Really good talk. I appreciate that, and thank you for allowing us to record it so that we can show it to our broader audience in the through our website. A lot of lessons learned and a lot of resonance with what we're trying to do with Nitro as well, because ultimately, although we're a network of individuals who are leading research organizations, we are part of teams. We're part of teams. Leadership is not a solitary activity. It is a team activity. I wonder if there are any questions from the audience at all. If not, I'll start off with one, which is, in effect, you've had the opportunity, because you've had so many different groups going through, to in effect take an experimental approach towards the way in which you try out different methods and mechanisms and processes to lead to positive outcomes in your theory of change. Did you adopt an experimental approach, or did you just sort of learn by doing and iterate the process as you went along?
No, we definitely took an experimental approach. The difference here is that we were committed to helping teams. We never designed the center to provide scholarship on how to do this kind of work. We felt it would be unethical to withhold any support from a team that we thought might help. So that means it's more like adaptive leadership per se. And that's where I mentioned the developmental evaluation. We would actually, the leadership met regularly, and we talked about what happened in teams, what went wrong, what worked. We made a point to, during the social times with teams, to spend time with them and talk to them. And then that would influence what, we might do the next time. So it was experimental, but it wasn't a controlled study. The closest we've come to that is the graduate student program that is being led by not by myself. John Kramer and another individual helped to design that. So it's a different way to lead a center, but I think that's the way you have to do this. One of the problems we've had that what you said reminded me to mention is that this isn't necessarily transferable to a university. And it's partly because, first of all, we had lots of funding. You almost never have that level of funding. We were very fortunate. But second, people were working outside their university. So it was outside the stovepipes. It was outside the politics and the dynamics on campuses. So what I've told you about today is not something that I think would work at the University of Maryland. And I've been very honest with people about that. Universities are very stovepipe. So if any of you have great experiences in overcoming some of those hurdles within the university setting, I'd love to hear more about it.
Thank you. Alana, you've got a question?
I do, and it does flow on nicely from what you just said, Margaret. Thank you very much for your presentation. I really enjoyed it. So, I'm not research active at the moment. My role is as Director of Sustainability at Massey University, which covers a whole lot of things, but I have been an academic, came from a background as a sociologist, and have just really been interested in wanting to do more and to encourage, foster interdisciplinary, transdisciplinary research at Massey. So my question really was, we had some funding a couple of years ago, pre-COVID, which was deliberately focused on setting up teams which were transdisciplinary and focused on the grand challenges. And many of them didn't work very well for all the reasons that you've kind of talked about. So my question for you really was going to be, and given that we have the funding is relatively limited, what are the one or two things that you would say would work within a university just to, I suppose, get those conversations going or mobilize people who are already possibly in a place who, so it's not that this work isn't happening and these conversations aren't happening, but it's bringing on, I suppose, for me, I'm looking at younger academics and how we nurture and foster them. That may be an impossible question, but any thoughts would be?
Yeah. Yes and no, Elena. What I will say is that the younger people are hungry for this. They want to make a difference. So this is where throwing ideas out there and opportunities that have social implications tends to pull people together. It really does. Social activities are important. People get to know one another. It does make a difference if there is a little bit of funding to get groups together, but we've still found, particularly the younger people and the assistant professors, want to do this if somebody is willing to provide a little bit of leadership and help sort of tell them how to do it. So I do think it's possible. It's just harder. My view towards my own university was to try and change things from the bottom up. We had NSF asking us to try and do something for deans and provosts, and I felt like that would never work, that you have to appeal to the researchers. So
thank you. I mean, that makes sense. I think the whole idea of social activity, and I guess we've been, you know, COVID has stopped a lot of that, and we're just now kind of reawakening, I guess, in sense of, and there's a great desire for people to come together. So thank you, that's helpful.
Yeah, I think so too.
I am just a little vignette. I was fortunate enough to be involved in the design of a couple of new buildings for fostering inter and transdisciplinarity, and one of the things that I did was make sure there was one common tea room, right, rather than a set of separate tea rooms, because that means that people sort of tend to go into their isolationist groups rather than mingling and interacting. And
no, it's absolutely good coffee. If you can have snacks, people will come. We actually at SESYNC said, you can come get coffee and cookies or whatever, everybody's welcome, but you have to talk to a few people before you leave. You can't just come pick them up and go. And people actually did it, but you're right. In fact, every time I have had a meeting at the university where I'm trying to do anything similar to this, I bring food. People come. It's really amazing.
Yeah. Good.
But good for you. If you've been able to design buildings, having space people have to walk through to get coffee and see each other makes a difference.
Yeah, absolutely.
Maybe one other question, and then I'm probably going to beg off. But
yeah, no, absolutely, and I think probably we can stop it there, because the others have had to go because of it's sort of middle of the teaching semester, so folks are having to go. So thank you very much indeed, Margaret. It's been a real pleasure to listen to you, and you're probably one of the people in the world that's had the most experience of how to do this thing that we all talk about, and a lot of what you talked about resonates with me, and I'm sure with other members of the Nitro community. So
definitely.
Once
well,
again,
thank you, Ian. It's been a pleasure, and I've learned a lot from all of you as well. So thank you very much, and thanks for staying up, Ian.
It's 1 a.m. Well, it's 2 a.m. with me now.
I know.
Okay.
I know. I'm impressed.
Okay.
All right, everybody, take care.
Thank you. Thank you, Margaret. Cheers. Take care. Bye.